Welcome to CS 1401 Video 17.2. In the last few videos, we've been learning about how to create and use objects. And we also just learned about recursion. We can combine objects in recursion to do some amazing things. And in this video, I'll introduce you to one of these amazing things, linked lists. If I have some animals, say 2 ducks, a goose, and a fox, I can represent them as data type string. Moreover, I could create for each animal an object with a single data field of type string that would contain the label for the animal. If these animals were entering the forest one by one, it would be nice to be able to represent the list of animals in that order. Perhaps a duck goes into the forest first. If another duck goes next, I'd like to have a way to remember that this next animal was the second duck. And if the goose goes next, I'd like to have a way to remember that the next animal after the second duck was the goose, and so forth. Here's a way to remember who came first and who came next. For each animal, the object for that animal has a data field for the animal's label, and I'll add a data field that references the next animal. That way, for each animal, I can have the next field point to the next animal. That is, each object, which I'll call a node, has a data field containing a string such as duck, and a next field containing a reference to the next node. For the last node in the list, the next field points to null because there isn't any next node. And I can refer to the list with a variable, say, my animals, that contains a reference to the first node of the list, which I'll call the head of the list. Let's look at a pseudocode representation of the class node. Each node object has the 2 data fields I've mentioned. A string variable named data that contains the node's information, and a node variable named next that contains a reference to the next node. Notice that the definition of node is inherently recursive. The class is node, and one of the class's fields is of type node. The pseudocode representation of the class linked list is very simple. The class has only one field, and it's a variable of type node named head that points to the first node in the list. That's an introduction to linked lists in terms of pseudocode. Java actually has a class called linked list. But for our course and this video, we'll implement our own version of linked list. So here's my Java implementation of the pseudocode for linked list. I'll start with the class node. Just like the pseudocode, the class has 2 fields, a string named data and a node named next. Because the node next is an object of class node, the field next is what's called a reference variable. The content of the variable is a reference to the object. Informally, we can call this reference a pointer. The only other part of the definition of class node is its constructor, which has a single parameter of type string and which sets the data field to that string and the next field to null. Actually, there will be one other method for node, but I'll get to that in a couple of minutes. Let's look for now at the Java implementation of the class linked list. There's only one instance variable, which is of type node, and is called head. Basically, the purpose of the linked list class is to have a way of referring to the node that's the head of a list, and that's what the instance variable head does. The constructor for linked list creates a linked list with no nodes in it yet. The variable head points to null. To add nodes to the list, we'll need a method called addNode. And to delete nodes, we'll also want a method called delNode. I'll get to the addNode and delNode methods in just a moment because there's something really cool we can do next. We've arrived at the point where we can seriously combine objects and recursion. To illustrate this, I'm going to write a method for class node that prints the entire list starting with that node. Here's my idea. For the current node, print that node's data. Then, if there is a next node, recursively call print for that node. Of course, if there isn't a next node, then the current node is the tail of the list, and there aren't any more nodes with data to print. The base case is implicit. If there's no next node, then there's nothing else to do. Here's my Java implementation of print. The method doesn't return a value, so its type is void. It has no parameters. What it does do is print the string in the data field, and if there's a next node in the list, have that node recursively call print. And that's it. Clean, recursive, simple. So given any node, now we can print out every element of the list, in order, starting with that node. I'm also going to include a get method for node that returns the string in the data field. To give a practical idea of what we might do with the class linked list, here's an example. I'd like to create a playlist for some songs. The list will be a list of titles of songs. For example, Friday I'm in Love, She Loves You, and Mr. Tambourine Man. Here's some Java code that builds this list. I'll create a new empty linked list named the playlist. Then I'll add the 3 songs one by one. To do so, I'll use the add node method, which I'll get to next. I'll add another node for the song April Love, and then print the list using the print method I just wrote. I'm going to print an extra line here so that when we see the program execute, it will be clear which list is which. Then I'll delete the node for April Love, which is a song I don't like. And finally, I'll print the list again, and this time it shouldn't have April Love in it. A couple of notes. First, this implementation of linked list is what's called first in, last out. That is, the first node I add will be the tail of the list, and the latest node I add will be the head of the list, and the first node to be deleted. Second, although I implemented my class node and class linked list so that each node's data field contains a string value, I could have written these classes with any other data type for the node's data. In fact, the content of a node could even be an instance of another class. But for now, we'll stick with strings. My program relies on the methods addNode and delNode, so I better include them as methods in the linked list class. I'll start with delNode, which is the simpler of the two methods. In fact, it's really simple. Let's have a linked list named SomeAnimals that has 2 nodes, goose and fox. To delete the goose node, I just point the head of the list to the fox node instead of the goose node. Now the linked list field head points to the node for fox, and the node for goose isn't in the list anymore. Next, here's how to add a node. Let's say I want to add a node for duck at just before the node for goose. I'll create a new node with data duck, and I'll refer to that with a variable named tempNode. Because the duck node will come before the goose node, I'll set the next field of the duck node to point to the goose node. Now all I have to do to complete the adding of the duck node is to have the head variable of the linked list SomeAnimals point to the duck node instead of the goose node. I know how to do that because I have the variable tempNode that has the pointer to the duck node. TempNode was a local variable, so it will go away when the method terminates. And once the head field of SomeAnimals points to the duck node, we're done. Those are the algorithms for delNode and addNode. Let's take a look at their implementation in Java as methods in the linked list class. As I said, del node is pretty simple. I just change the value of the head to the node in the head of node's next field. A rigorous implementation would guard against the case where head is null. For purposes of this class, I want to keep the code as simple as possible so that you can understand what's going on. The method for add node follows the algorithm described a few moments ago. I'll create a new object of class node whose data field is the string passed as a parameter to the add node method. I'll refer to the new node with the variable temp node. Next, I'll set the next field of the new node to point to the node that's currently the head of the linked list, and which will be the second node in the list after the new node is added. Finally, I'll set the head of the linked list to point to the new node. And that's it. Now we have everything we need to try out the playlist program. Class node with the print method, class linked list with the add node and del node methods, and the playlist program to test everything. Remember that playlist's main method will create a new linked list, add 4 songs, print the songs, delete 1 song, and then print the list again. So I'll compile node, linked list, and playlist. Now I can run playlist. And the output is exactly what I expected. There is the list of 4 songs, with the last song added being April Love. There's the blank line I included to make the output clear. And there's the list of 3 songs after April Love was deleted. Thank goodness. Pretty cool. We've been able to combine objects in Recursion to create a linked list data structure. We'll explore lists and recursion in much greater depth when we look more at the Prolog programming language a little later in the course. In the meantime, I'll see you in the next video.